Okay, so this is a paper 2 question on functions from the January 2016 paper. It's a part of question 9. Actually, this was one of the ones that I could find with 8 marks altogether, because a lot of the functions questions, they're probably around 5, 6, or between 5 to like 9 marks. But remember though that it's spread across different questions. So even though all of them are not in one, you're going to see it in different parts of the paper. But this one was focused purely on functions. So anyways, we're supposed to find, given the functions f of x and g of x, as f of x is 3 over 2x plus 1, and g of x is x squared, we want to evaluate g of negative a half, fg of negative a half, and f inverse of x. So let's get to it. Let's start with number 1. So we want to find g of negative a half. Now, remember that this means we are putting negative a half into g. So wherever we see our input in g, which would be, let me get the highlighter instead, which would be here. That means I'm going to put negative a half right there. So g of negative a half, let me change the color back to blue. Sorry about that. So g of negative a half is going to be negative a half all squared. And negative a half all squared is going to be equal to negative a half times negative a half. Negative 1 times negative 1 is 1. 2 times 2 is 4. So that means g of negative a half is equal to a quarter. Very important to remember that we square all of this. Negative a half is all of our input. So that means we're going to square all of negative a half. Okay? Good. Now let's go down to question, or the second part of I, where we're supposed to find fg of negative a half. Finding fg of negative a half. Now if you notice, or as you realize, this is a composite function, and that means we are putting one function into the other. So here we are going to be putting g of negative a half into f. Putting g of negative a half into f. Let me just go back up. So we know that f is 3 over 2x plus 1. Now, whereas with other composite functions, if we had an x here, that means we'd have to put the function into the other in terms of x. But no, we already know what g of negative a half is, right? Because remember, we just figured out that g of negative a half is a quarter. So I can replace my g of negative a half, right? And what it's really saying is that I'm just putting a quarter into f, because g of negative a half is a quarter. So now all I need to do is put a quarter into f, right? So that means I'm going to put my quarter here where I see x. So now that means I'm going to rewrite this. Let me come down. Instead of 3 over 2x plus 1, this is going to be 3 over 2 times a quarter plus 1. 2 times a quarter. So that's going to be 3 over, we know that 2 times a quarter. Let me write it here. 2 times 1 over 4. 2 into 2, 1. 2 into 4, 2. So that would be a half. So that's going to be a half plus 1. A half plus 1 is the same thing as 1.5, or 3 over 2. And there are a lot of ways that we could proceed from here. One way we can think about is that this is 3 over 2, right? And what this is basically saying is that 3 is being divided by 3 over 2. If we're dividing it, that means we're going to keep the first and second fraction. So that's 3 times 2 over 3. And 3 can go into 3 once each time. So that's going to just leave us with 2. So that means fg of negative a half is 2. Alright, so we've found g of negative a half, we've found fg of negative a half, and that means we can move on to our second part, which says that we want to find f inverse x. We're looking for f inverse x. So do you remember how to find the inverse function? Basically, we can use the concept of transposition, right? So first, we let y be equal to f of x. So that means y is equal to 3 over 2x plus 1. And now we are going to solve for x. So I should rather say solving, because it's going to be something that we're doing. So solving for x means that I'm going to come down here and I'm going to start. So I had y equals 3 over 2x plus 1. I need to get this out of my denominator so that I can make things easier for myself. So if I do the opposite operation over here, now I'm going to be, because I was dividing by 2x plus 1, now I'm going to be multiplying on the left hand side by 2x plus 1. So that's 2x plus 1 times y is going to be equal to 3. Let me expand my bracket. That's going to be 2x times y, 2xy, 1 times y, that's plus y, so that's 3. So that means 2xy is going to be equal to 3 minus y. So 2xy is equal to 3 minus y. I want x by itself, so that means I can divide both sides by 2y. X is going to be equal to 3 minus y divided by 2y. Now that I've solved for x, I can change back my x to f inverse of x, because that's what x represents, and I can change y to x to represent my new input. So f inverse of x is equal to 3 minus x over 2x.